What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exam. So let's get into it. In this video, you are going to learn about threat vectors such as message-based, image-based, file-based, voice calls, removable devices, vulnerable software, unsupported systems and applications, unsecure networks, and open service ports. All right, so let's talk about message-based communication. So message-based communication like email, SMS, and instant messaging has become essential to interpersonal and professional interactions in today's digital connected world. These platforms are quick and convenient, but they also provide a sizable surface for online threats. And these messaging techniques are widely used, which makes them a desirable target for attackers who use a variety of strategies to take advantage of users. The message-based threat vectors take advantage of the trust and immediate nature of these forms of communication for everything from phishing and smishing to the spread of malware. Next, let's talk about email threats and cybersecurity. So one of the most prevalent threat vectors in cybersecurity is email. Attackers frequently use email to spread malicious links or attachments that can cause a user system to download malware. Phishing emails are extremely common, and they may pretend to be from reliable sources to trick users into disclosing personal or financial information. A more specific variation of phishing, which is known as spear phishing, this targets particular people or organizations and is frequently conducted using information pertinent to the target. Now, combining technological safeguards like spam filters and secure email gateways with ongoing user training to spot and avoid suspicious emails, this is necessary to protect against these email threats. Next, let's talk about short message service or SMS. So this is also known as text messaging in case you didn't know, but SMS, this is a threat vector that cyber criminals frequently use. SMS, this is a method used to provide one-time passwords to different types of one-time password services, and attackers, they may use SMS messages to trick recipients into downloading malicious software or divulging personal identification by including links to phony websites. And this is called smishing, which is a combination of SMS and phishing. And smishing attacks frequently pretend to be from a bank and say that the recipient's account has been compromised to convey a sense of urgency. And we will talk about smishing in greater detail later on. And users, they may be more likely to fall for these scams than other types of attacks because SMS messages are considered more private and less vulnerable to security risk. However, it is crucial to inform users about these potential risks. Next, we have mobile device authentication via SMS. So mobile devices with SMS text capabilities can be used for authentication via a one-time password and challenge and response. With authentication via an OTP, a one-time password is sent to the user's phone via SMS, and the user enters the OTP into the login authentication and is approved. Next, we have the challenge and response authentication methods. So with one form of challenge and response, a user receives a text asking them to tap yes or no. This is a less secure form of strong authentication because it is vulnerable to on-path attacks, which are also known as man-in-the-middle attacks. Now, with another form of challenge and response, the user receives a text asking them to reply via SMS. If the user texts back yes, the authentication is completed and the user is logged in. If the user texts back no, then the authentication fails and the user is not logged in. And SMS is susceptible to a SIM takeover, brute force attacks, key logging, on-path attacks, phishing, and common computer access attacks because after all, most cell phones are computers. Next, we have instant messaging security. So instant messaging platforms are widely used for personal and business communication, which means they are also targeted by cyber attackers. And attackers may use instant messaging to spread malware via nefarious links or attachments, take advantages of holes in the IM software, or carry out phishing scams. In contrast to email, instant messaging frequently conveys a sense of immediacy and trust, mainly if the attacker has gained access to a known contact's account. People may therefore be more likely to click on harmful links or heed misleading instructions. And the use of current software with security patches, proper authentication techniques, and user education on spotting and reporting suspicious activity are all examples of security measures for instant messaging. Next, we have spam and spam over internet messaging, which is also known as SPIM. So spam has traditionally been the term used to describe unwanted and unsolicited email messages. However, email messages are not the only way that attackers or malicious users send spam. Users may also receive spam or numerous messages via social media sites and instant and internet messaging applications. So for instance, you might be talking to other security professionals over a Discord server and have someone hop on the server and send dozens of unwanted messages, perhaps protesting against something. Or you may receive unwanted messages and scam offers via Facebook Messenger, WhatsApp, Keybase, Signal, WeChat, Telegram, or any other instant messaging application. And as a tip, there are several free services that enable you to obtain DNS-based blocking lists of spammers, as well as ways that you can report spam events. All right, next, let's talk about image-based threats. So digital images are an essential part of today's online content, but can also be used as a vector for threats. Image-based threats refer to the malicious manipulation or exploitation of digital images to hide or deliver malware, engage in phishing activities, or execute other harmful actions. And attackers, they can embed destructive code within an image or manipulate its metadata to spread malware through email, social media, or other online platforms. And the hidden code may be executed when the image is open, leading to a system compromise. Now, safeguards such as updated antivirus and anti-malware software and cautious downloading from untrusted sources can help mitigate this risk. Next, let's talk about file-based threats. So file-based threats, they use common files such as documents, spreadsheets, or PDFs to carry out harmful scripts. And these threats occur when malicious code is embedded within or attached to these files, which are transmitted or shared to infect systems or networks. And this type of threat is common in attachments sent via email, downloaded from websites, or transferred through file sharing services. So opening such files can trigger malicious codes, leading to unauthorized access or other adverse effects. So awareness and training, scanning of attachments with security tools, and strict file permissions, all of that can help to minimize the risk. Next, we have what are called voice call threats. And these encompass a range of malicious activities conducted via phone calls, including deceptive practices such as vishing, which is voice phishing, unauthorized call interception, and fraudulent caller ID spoofing. These threats aim to deceive or manipulate individuals through telephone communication, and often an attacker impersonates a legitimate entity to solicit personal or financial information or manipulate caller ID information to appear trustworthy. And a way to protect against voice call threats is to secure all authentication methods, develop awareness and user training, and report any suspicious calls. And all of that will be critical defenses against voice call threats. Next, we have removable device threats. So using portable storage devices like USB drives, external hard drives, or memory cards can inadvertently introduce removable device threats, which are risks associated with transmitting or carrying malware via these devices. When an infected removable device is connected to a computer, the infected machine may execute the malicious code, leading to data theft, system compromise, or spread of malware to other connected systems. Implementing policies restricting the use of removable devices, scanning them with up-to-date antivirus, anti-malware software, and once again, educating users about safe handling practices. This also can help to mitigate these risks. Next, let's talk about vulnerable software. And this is software that has flaws or weaknesses in its code or design. Attackers can exploit vulnerable software to gain unauthorized access, disrupt operations, or cause other malicious activities. Now, to avoid vulnerable software, it is essential to understand the context concepts of client-based and agentless security solutions. So the first one we have is client-based security, and this requires the installation of software or an agent on a client device itself, whether it's a computer, mobile device, or network appliance, and the agent actively monitors and protects against malicious activities such as exploiting software vulnerabilities. And it can provide more granular control and customization, but it may be more resource intensive. And then we have what is called agentless security, and this doesn't require the installation on individual client devices. Instead, it involves centrally monitoring and enforcing security policies, often through network devices or virtual appliances. And an agentless approach, this can offer a lighter footprint and easier management, especially in diverse environments with various devices and operating systems. Now, both approaches, they aim to protect against the risks associated with vulnerable software, but they do so in different ways. Client-based solutions may provide deeper insight and control at the device level, whereas agentless options might offer more extensive coverage with a reduced maintenance burden. So choosing the right method depends on organizational needs, the complexity of the environment, and specific security requirements. Next, let's talk about unsupported systems and applications. So unsupported systems and applications are software tools or platforms that do not receive regular updates, security patches, or technical support from the developer or vendor. And this situation often arises when a software version reaches its official end of life, or the company that developed the software goes out of business or discontinues support for particular products. And the security risks associated with unsupported systems and applications can be high, particularly when known vulnerabilities remain unaddressed. Without updates, systems become prime targets of cyber criminals who may exploit unpatched flaws to gain unauthorized access, manipulate data, or launch broader attacks in an organization. Now, for businesses operating in regulated industries, using unsupported software can also lead to non-compliance with legal and industry standards, resulting in fines or other penalties. And to mitigate these risks, organizations must upgrade to supported software versions or implement specific security controls that adequately safeguard unsupported systems. And a detailed inventory of all software and a regular review of support status is essential to an effective cybersecurity strategy, ensuring that unsupported systems do not become a weak link in the organization's security posture. All right, next let's talk about unsecure networks. So unsecure networks need to have appropriate security measures to safeguard the data transmitted, and they can be categorized into different types such as wireless, wired, and Bluetooth, each with distinct characteristics and potential vulnerabilities. So I'm going to go ahead and provide a general overview of these types of networks. So the first one is the wireless network, and this is a network in which devices are connected without physical cables. Wireless networks that are improperly configured or they lack robust encryption protocols, they can be susceptible to unauthorized access and eavesdropping. And attackers, they might exploit weak Wi-Fi passwords or outdated security standards like WEP to intercept data or create rogue access points to mislead users. Then we have wired networks. So wired networks, these are where devices are interconnected using physical cables and are generally considered more secure than their wireless counterparts. Wired networks, they can still be vulnerable if proper segmentation and access controls are not implemented, and attackers with physical access to the network cabling or ports might intercept data or introduce malicious devices such as network traps. And then we have Bluetooth networks, and these allow short-range communication between devices. However, they can be exploited if devices are set to discoverable mode or if known Bluetooth protocol vulnerabilities are not patched. And attackers, they may launch attacks such as Blueborn to spread malware or gain control of devices. Now, an unsecured network exposes an organization or individual to potential cyber threats like data theft, on-path attacks, or unauthorized control over network devices. Proper security measures such as robust encryption like WPA3 for Wi-Fi, network segmentation, firewalls, and continuous monitoring, this all can mitigate these risks. Also, educating users about the dangers of connecting to untrusted or open networks and enforcing policies to guide safe network usage are essential strategies for enhancing network security. Next, we have what are called open service ports. And open service ports are network communication endpoints that are left accessible and unguarded on a computer system. Applications use these ports to communicate with other devices over a network. In open service ports, they can present a significant security risk when not adequately secured. An open service port can be compared to an unlocked door in a building. Just as an unlocked door allows anyone to enter, an open service port can allow unauthorized access to an application or even the underlying operating system. And attackers, they can exploit open ports to conduct activities such as information gathering, service disruption, or remote control of the system. So here's a tip for scanning your computer ports. So if you want to identify open ports on your computer, you can run a simple test using the Windows command prompt. So just open the command prompt and enter the following command, netstat-ANO. Then this command will display all currently existing network connections via open ports and open listening ports that are not immediately establishing connections. Now, the risk associated with open service ports can be mitigated through proper security measures such as the following. So you have port scanning. So regular port scanning, this is an essential practice for maintaining a secure network environment. Among the most widely used tools for this purpose is Nmap, which is also known as Network Mapper. And Nmap, this is a versatile and powerful open source tool that is capable of discovering hosts and services on a computer network. And another tool is called Maskin, which is known for its speed and serves a similar purpose to Nmap. Netcat is more straightforward than Nmap and offers excellent functionality, including port scanning, file transfer, and the setup of backdoors. By regularly employing port scanning tools like Nmap, you can identify which ports are open and take appropriate action to close or secure unnecessary ports. Then we have firewall configuration. So by using a firewall to control the traffic allowed to enter or exit through specific ports, you can block unnecessary ports, thus limiting your exposure. Then we have monitoring and logging. So it is a good idea to implement continuous monitoring and logging to detect suspicious activities on open ports and take corrective actions if needed. Then we have patching and upkeep. So one way to secure a network is to ensure that these services running on open ports are up to date with the latest security patches and configurations. So ultimately, by understanding the necessity of each port and applying appropriate security controls, organizations can significantly reduce the risk associated with open service ports and enhance the overall security posture of their systems. All right, so that was my video where you learned about threat vectors such as message-based, image-based, file-based, voice calls, removable devices, vulnerable software, unsupported systems and applications, unsecure networks, and open service ports.